Hello, welcome. Let's try to solve another Leetcode problem. 1559. Detect cycles in a 2D grid. I think this problem is really easy to understand. And the cycles will be like this. So for example, in the drawing, so for each of the cell, it can go to 4 directions. So this is 4 directions. So in the 4 directions, if it is always to be A, so now we have a cycle. So this will be a cycle, and another one with 4 B's, it's gonna become another cycle. Yeah, so definitely there's cycles in this kind of a grid, so we're gonna return true. So if there's no such cycles, we're gonna return false. Yeah, so for the second example, and because it can go to 4 directions, so there is still another cycle, so we're gonna return true. But for the third example, there's no cycles, so we're gonna return false. I think there are basically 3 ways to solve the problem: BFS, and unified for detecting a cycle. So this is a 2D grid, so we can use a 2D grid unified to solve the problem. Yeah. So the idea is that we're going to use unified to union them together. So for example, for the unified, definitely we can have this kind of a pattern, so we can go to the right and bottom, or another pattern is we can go to the left and up. Yeah. So basically, we can prepare 2 kind of patterns to loop through the grid for the unified. We can go to the bottom. We can go to the bottom left, or we can go to the bottom right, or we can go to the top left. Yeah, basically we can use 2 patterns for the unified, for using the unified to solve the problem. So for example, we're going to use maybe, let's just try the left and top. Yeah, so it can go to the left and it can go to the top for the unified. So for this A, it is okay because there's nothing. And then we're going to check this A and go to its left, and because they are the same, so we're going to union them together. And similarly for this A, so currently we're going to union those 4 A's together. Yeah, and we can also check the top, but there's nothing at the top. Yeah, now let's just continue. Let me clear a little bit about these areas. So currently those 4 A's are connected. Now we're going to continue for the unified, and for this A, because we can go to the top and the left. At the left there's nothing, at the top there's the A. So we're gonna union them together, so we're gonna connect them. Yeah. So this is a B. So what are we gonna do? Because they are not equal, so we will not do anything. And this is B, we're gonna union them together, and this is A, we're gonna union them together because we can go top and left. Right. Because this B not equal to A, so we will not connect them. Now we will continue for the unified. So we're gonna go to the top and left. Yeah. So top and left, we union them together, and there's nothing at the left. And for this B, we can go to the top, union them together, and then we're gonna continue. Yeah. Left it is A, we will not connect them. And for this B, we can go to the top, we're gonna connect them. And now what happens if we go to the left for this B? Because this B and this B has already connected. So this means we can use unified to solve the problem. If they have already been connected and they are the same characters. Now we're going to return true because definitely this is going to become a cycle. Yeah. So if we didn't return true, maybe we're going to wait. So we're going to continue for our algorithm. So we're going to connect this together, and here together, and yeah, because we can go the left and up. Yeah, so for the left, we're going to connect them together. Maybe we're going to check the up. Yeah, but this A has already been connected with this A. So while we're checking the up, but it has already been connected, so we're going to return a true. Yeah, so this is the second pattern of return a true. So this is why we can use unified to solve the problem. Yeah, it's going to be really easy. It's not like DFS. We may make a lot of mistakes, or BFS, but unified it's really easy to understand. So this is the first pattern. Or maybe we can use the second pattern. We can go to the bottom and the right. It is the same idea. You can try it for yourself, but I believe it is the same idea. But let's just try a little bit about this B. So we're gonna use another pattern. So this pattern gonna be it's gonna be the I forget which pattern I prepared. It's gonna be the right and bottom. So this is gonna be another pattern. So let's start with this B. So go to right, we're gonna connect them. This B go to right, but they are not equal. We will ignore them. But first go to right and then go to the bottom. We're gonna connect them. And for this B, similarly, go to the right, go to the bottom. We're gonna connect them. And then we're gonna continue to check this B. So go to the bottom. It is A, we will not connect, and go to the right because this B has already been connected with this B. So we're gonna return a true. So it's the same idea. So basically for the unified, if it is a grid, we have two patterns. One pattern is go to the bottom and the right. Another pattern is go to the top and the left. Because by using either of the patterns, we can connect them all together. Now let me just try to copy some other code. Maybe I'm gonna use the pattern from the number of islands. Because I've solved this problem by using the unified. Let me find if there's some unified code for this problem. It's not here. I'm not sure if I can find a unified pattern. Maybe here. Let me find a unified pattern for this problem. The number of islands pattern, because it's basically the same. I just need to change some code. So this is a unified in a grid pattern. So I don't want to explain it once again for the same problem. I just need to copy the previous code. So this code is coming from Leetcode 200, number of islands. Let me copy it from here. So this is the pattern, the unified template. And I'm gonna prepare a parent array, and I'm gonna prepare a rack self.rack. So this rack just means how many numbers of the connected component. But for this template, it is just for speed up a little bit. So so this is the path compression. For the path compression, we're gonna speed up a little bit. Here is self.parent equal to self.parent with self.parent with this value n. And this is racking, just to speed up. And this is the union, and this is find. And this is just to check if two dots are connected or not. So it's connected means they are connected. Now let's just check the code. So for this one, it is a grid. So we're gonna prepare RC as grid and grid 0. And we're going to prepare two directions 1 0 0 1, or you can prepare like minus 1 0 0 minus 1. It's the same as I explained. There are two patterns for the unified, two directions for the unified. We don't need to prepare 4 directions, just 2 directions. That is okay. Now let me delete this one. We don't need it. And this is the unified for 2D grid, and we don't need to have this one. Let me check from here. So for our checking, we have the 2 directions, and this row and column is for the 2 directions. So we're gonna check if it is inside the bounds, and if this grid row and column here is 1, if they are equal to, let me change a little bit, grid row and column, if they are equal. Now we need to check if they are not connected, so we're gonna connect them together. So else, if they are connected, so we're gonna return a true immediately. Otherwise, we're gonna return a false. As you can see, this problem actually it is easier than the problem. It is easier than the problem of number of islands. Leetcode 200. Let me just copy it from here and delete these areas. Now let me check again if everything's okay. This is my unified, and this is just to check the unified. If they are not connected, I'm gonna connect them. If they've already been connected, I'm gonna return true. So if I cannot return true, finally I'm gonna return a false. So this is gonna be the entire code. As you can see, the coding is much longer than we expected, but everything is just copy and paste. We just copied the previous code before. We didn't change too much. Yeah, just a little bit. And let me just run it. As you can see, it works. And now let me submit it to SAC if it can pass. Yeah, as you can see, it passed all testing cases, and it's pretty fast because for this algorithm, the time complexity is m times n. Yeah, basically for these areas, we can understand it by log n time or O1 time because it uses the path compression and reckon. Basically, it can let it become O1 for the unified. Yeah, so this is just 2 for loops, and for the directions, it is okay because there are only 2 directions. So this is why the time complexity is m times n. Now, let's just change another direction. Maybe if we want to change another pattern, it is -1, 0 is -1. Yeah, it's also the same. Let me just prove it. It should be the same as I explained earlier. Yeah, as you can see, it also works. So this means for the 2 directions, if it go to the right or go to the bottom, or another pattern, it go to the left and go to the top, it's just the same idea. And yeah, everything should be okay. So thank you for watching. See you next time.